Dear students, Assalamu alaikum. In this tutorial, we're going to learn tabulation method. So here is the question for our problem. Simplify the function using tabulation method. So here is the given function. So we're going to solve this problem in two parts. So we're going to describe part 1 first. So here is part 1. At first, we're going to take our question and we're going to write the mean terms sequentially from using an ascending order. Alright. So here the mean terms are written in ascending order and their binary bits are also written alongside those numbers. Alright. So the binary bits are written using 4 bits. Alright. So why did we use 4 bits? That's because the highest number given here is actually 15, and 15 can be represented by using 4 binary bits. That's why these binaries are written using 4 bits. And you can also see that there are 4 variables mentioned here, w, x, y, z. So from this case, we can also know that we're going to write those binary numbers using 4 bits. Okay, so the first step is to write all these main terms sequentially in an ascending order and also write their binary digits. Okay, so now we're going to create our step 2. So from this step, now we're going to group those binary numbers based upon number of ones in them. So we can see that from these numbers we can actually create 4 different groups. Group A, B, C, and D. So group A is actually indicating those numbers which have only 1 in them. Alright. So for group B there are 2 ones in them, for group C there are 3 ones in them, and for group D there are 4 ones in them. So we're going to group the mean terms based upon number of ones in them, and then we're going to put them into a different table, and that will be our step 2. So in step 2 we actually just divided all of our binary numbers into separate groups based upon number of ones in them. So our groups look like this one right now. So there are 4 groups in step 2, group A, B, C, and D. So now what we're going to do is we're going to find single bit difference from step 2. So how can we actually do it? So we're going to compare. So we will compare all the mean terms of group A with all the mean terms of group B, and then we're going to compare all the mean terms of group B with all the mean terms of group C, and then we're going to compare C with D. So basically what we're going to do is that we're going to compare only one group to its immediate next group. Alright, to its immediate next group. That means we're going to compare A with B, and B with C, and C with D. That's it. So let's just check a simple example. So at first we're going to compare 1 with 6. Alright, then we're going to compare 1 with 9, and then we're going to compare 1 with 10. So that's just for the comparison of 1. So we're going to do the same thing for the later ones. Like we're going to compare 4 with 6, and 4 with 9, and 4 with 10, and then we're going to compare 8 and 6, and 8 and 9, and 8 and 10. So after that our first 2 groups will be done. So we'll be finished with the comparison of group A and B, and then we'll compare B and C and D. So the whole comparison part will actually look like this. So we're going to compare A with B, and group B with C, and group C with D. We're not gonna compare A with C or A with D, alright, because C and D are definitely not the immediate next groups for A, and we're definitely not gonna compare B with D because D is not the immediate next group of B. Alright, so we are only gonna compare one group with its immediate next group. Okay, so let's continue. So during the comparison we're going to compare all the mean terms of one group with all the mean terms of its immediate next group. So at first let's check the scenario for A and B. So we're going to compare 1 of group A with all the elements of group B. So at first we're going to compare 1 and 6, and here you can see that we have written them individually right there. Okay, so what are we trying to get out of here? So we're trying to find single bit differences. So let's see, for 1 and 6 you can see the binary numbers are written over here. So we can see that there is 1 difference, and then there is another difference, and then there is another difference. So there are basically 3-bit differences over there. So we cannot consider it, we cannot take that, we cannot take this pair, so we're definitely going to discard it. So let's check the next comparison. So we're going to compare 1 with 9. So you can see that we have only 1 bit difference right over there, and all the other bits are actually the same for both 1 and 9. So there is only one bit difference, only single bit difference. So we are definitely going to consider this pair, 1 and 9. So we're gonna take it into consideration, and we're gonna put that into our step 3. All right, so this is what is actually written here. So this is the step 3. So since these pair actually match the condition of single bit difference, so we took this pair and put it into step 3. And in step 3, you can see that there is something written over here, some binary bits and a dash. So how did we actually put it? So here is the rule. We'll put a dash at the position where we find the bit difference and place the pair in step 3 as we did, and the other bits remain same for both the digits of the pair. Alright, so here you can see we have found the difference at the very first position of this pair. Alright, so that's why at the first place right there is a dash, and all other bits are actually the same. So that's why all other bits remain the same, 0, 0 and 1. Only at the first position we got the difference, that's why there is a dash. So that's how we're gonna be putting different pairs into step 3. So let's continue our comparison. So after that, we're going to compare 1 with 10, and you can see there are 2-bit differences, so we're definitely going to discard it. So now the comparison of 1 with all those numbers are done. So now we're going to move on to 4. So you can see when comparing 4 with 6, 9 and 10 from group B, we can see that only 4 and 6, this pair matches the condition of single bit difference. So there is only 1 bit difference right over there at the third place for 4 and 6, and since this is the there is only single bit difference, so we're definitely going to consider this pair. And for other pairs, we have found more than 1 bit difference, so we're going to discard it. All right, so for 4 and 6, we're going to put them into step 3, and we're going to write the binaries with the dashes. So how can we actually do it? So the difference was found at the third place from left side, the third place. So here you can see that at that specific position we have put a dash over there, and all other numbers actually remain the same. So this is what we get for the pair of 4 and 6. So we'll continue our checking for 8 now. 8 will be compared with 6, 9 and 10, and you can see that if we compare 8 with 6, 9 and 10, we're going to be getting actually these pairs. So I have not shown the whole procedure here because this is actually the same as before. So if we compare 8 with 6, we're going to get more than 1 bit difference, so we will discard that. But if we compare 8 with 9 or 8 with 10, then we're going to get something like this one. So for 8 and 9, 1 0 0 dash, and for 8 and 10, 1 0 dash 0. So this is the basic scenario after we're done with the comparison for group A and B. Alright, so here we can see that from group A and B we're actually getting these results. So the same thing will be followed for group B and C. Remember, we're only going to compare one group with its immediate next group. So for the next comparison, we're going to be comparing all the main terms of group B with all the main terms of group C. So we're going to compare group B and C, and the results will be seeing something like this. Alright, so 6, 7, we'll get this pair, and we'll also get 9, 11 pair, and we'll also get 10, 11 pair. All of these pairs actually match the condition of single bit differences. That's why we actually put them in step 3. So after that, we're going to be comparing group C with group D, and you can see that from the comparison of group C and D, we'll get the pairs of 7 and 15 and 11 and 15. So this is how we're going to be putting numbers in our step 3. So we're going to find single bit differences within our comparison, and then we're going to put that pair into our next step, step 3. So here from group A and B we got these pairs, and from group B and C we got these pairs, and from C and D we got these pairs. So this is what our problem looks like after we're done with the first phase of comparison. Alright. So this is step 1, step 2, and step 3. So now what we're going to do is that when we're done with the step of finding out single bit differences, in this case step 3, we're going to go back to the previous step, that means step 2, and put tick mark beside some of the numbers. Okay, so we're going to put some tick marks over there, step 2. So how will we actually put that? So let's see the rule. So we'll put tick marks beside those numbers on step 2 which we have taken as pairs in step 3. So what does it actually mean? That means you can see that in step 3 the first pair was 1 and 9. So we're going to go back to step 2 and we're going to put tick marks on 1 and 9. Alright. So next the pair is 4 and 6. So we're going to put tick marks on 4 and 6, just like that. Okay, so we're gonna do the same thing for all of those pairs. So let's continue. So for 8 and 9, we have put tick marks on 8, and the 9 was already ticked, so we did not put another tick mark beside that because it was already done. Alright, so after that 8 and 10, yeah, so you can see that we have put tick marks on 10, and the same thing will be done for all other numbers. Alright, so what we're doing right here is that whenever we're checking a pair, so like for example this pair is actually 7 15 right over there, and we're gonna go back to step 2 and we're gonna put tick marks on both 7 and 15. So the 7 was already ticked before, so that's why we have not touched it again, but the 15 was not, so we just put a tick beside 15 over there. Okay, so this is what we're saying right over here on this rule. So after after going through all the pairs and putting ticks, let me just show you the last one, 11 and 15. So both of these numbers are actually already checked, so that's why we don't put multiple ticks over there. Alright, so after checking all the pairs like we did here, so we're going to move on to step 4 now. Alright, so let's move on to step 4. So now we're going to find double bit differences. So what does it actually mean? It means we're going to check two different conditions. So we're going to check whether the dash position actually matches or not, and then another single bit difference. So let me just show you, it will be much easier. So basically what we're going to do is that we're gonna compare all the minterms of group A, all the pairs of minterms of group A with all the components of group B, just like before. We're going to compare it group wise. Alright, so then we're going to compare group B with group C. Definitely it means that we're going to compare all the elements of group B with all the elements of group C. Okay, so to compare that, we have to follow some conditions. We have to follow actually two conditions. So first we have to match the dash positions. Alright, first we have to match the dash positions. That means when we are comparing the first pair over here, so 1 9, so we're going to compare these binary number with the binary numbers existing in group B. So to do that, at first we're going to compare the dash position. So if the dash position actually matches, alright, then if the dash position actually matches, then we have to look for single bit difference. That means except the dash. The dash is already indicating a single bit difference, right? So what we're gonna do is that while comparing, we're gonna try to find out whether the dash position actually matches or not, and then if it matches, then we're gonna look for another bit difference. Alright, so that's how we're actually saying it as double bit difference. Alright, so let's just see the example of how it works. So let's say the first two pairs right here. So the pair of 1 9 from group A is being compared to a pair of group B 6 7. Alright, so I have written the binaries over there. So you can see that the dash position doesn't match. For the first number, the dash position is the first position, and the second pair we can see the dash is at the 4th place. So the dash position definitely doesn't match, and since it doesn't match, so we have absolutely no need to check the second condition right now, and it can be discarded. Alright, so let's check the second pair. So 1 9 is being compared with 9 11, and you can see the dash position doesn't match, so we're going to discard that one too. So let's move on to the third one. So 1 9 is compared to 10 11, and you can see that the dash position doesn't match here too, so we are also going to discard that. Alright, so we have compared the first pair of group A with all the pairs of group B, and we have not been able to match the first condition, the dash position match. Alright, so we have not been able to match the first conditions, that's why we didn't go through the second condition, and all of these comparisons were discarded. So let's see what happens next. So now I'm going to check the comparison for 4 and 6 pair. Alright, so for 4 and 6, you can see the numbers are written here, the binary numbers. So first 4 and 6 pair, it is compared with 6 7. So you can see the binary numbers over there, and the dash position definitely doesn't match. So since it doesn't match, so we're going to discard it just like before, and we're going to move on to the next comparison. So now we're gonna move on to 4 6 and 9 11. Okay, so you can see right there that for both of those pairs the dash is exactly at the third place, so the dash position definitely matches without any doubt. So yeah, just like that, the dash position definitely matches. So the first condition actually matched. So since the first condition matched, now we're going to try to satisfy the second condition. That means if the dash position matches, then we have to look for single bit difference. Alright, so the dash position matched. Now we're going to see whether we have a single bit difference over here. So you can see that there is a bit difference at the first position, and there is another bit difference at the second position, and another bit difference at the last position. So you know, there is actually no single bit difference. There are actually 3 bit differences for those pairs. So even though the first condition matched, the second condition didn't. So we're definitely going to discard those pairs. We're definitely going to discard this comparison, and we're going to move on to the next one. Alright, so you get the idea, I guess, that for a valid comparison you need to match both of these conditions, not only one. Alright, so let's move on to the next one. So here you can see that 4 6 is compared to 10 11. The dash position didn't match, so we're definitely going to discard this one. Okay, so we are going to continue the same thing for this 8 9 pair now, and we can see if we continue our comparison, then the 8 9 pair will actually match with the 10 11 pair over here. So let's see how it can be done. So you can see the binaries. So you can see that the dash position actually matched right there. Both of the dashes are at the 4th place, so the dash position matched. Yeah, first condition matches. So now let's see whether the second condition is satisfied or not. So here you can see that we're getting only 1 bit difference, only the third position right there, only this bit is different for both the pairs. Alright, all other bits are actually same. So you can see that for this case our dash position actually matched. Okay, so let me just rewind it. So at first the first condition matched, the dash matches. Alright, so since it matched, now we're going to find a single bit difference. We're going to see whether there is a single bit difference for these pairs, and you can see that there is only 1 bit difference. That means it's a single bit difference, and since both of the condition actually match, that's why we're going to consider these these pairs, and we're going to put them into our next step. So let's see how we can do that. Okay, so once we get such scenario, we're gonna put those pairs into step 4. So here we have put both of those pairs into step 4, and we'll write them together, 8 9 10 11, and we have written something over there. So let's see how we actually did it. So the previous dash will stay as it was. Alright, so that means the dash which was already there, this is the dash, the at the 4th position, this dash was already there, so it will stay as it is. We will not touch that. Alright, so we're just going to put a new dash where we're getting the new difference. Alright, so we're getting the new difference at the third place, so that's why we put a new dash over there. Alright, and the rest of the numbers stay same. So that's how we're going to put our new sets of pairs into our step 4. Alright. Okay, so if we continue our checking, we'll be seeing that the 8-10 pair of group A also matches with the pair of 9-11 from group B. You can see that the dash position actually matches. Both of the dashes are at third position, and we can also see that there is only 1 bit difference over here. Alright, so dash position matches and there is only 1 bit difference, so we're gonna put them into our step 4 too. So here, just like that, 8-10 and 9-11 all join together, and previous dash will stay as it is, and for the new difference we'll put a dash over there. That's it. So that's how we're going to be putting numbers into step 4. Okay, so you can see a thing over here, both the rows look exactly same. That means both of these rows look exactly same. The binary numbers, actually the binary numbers and the dashes look exactly same. That's because if you see over here, you can see that all of those numbers are actually the same. 8, 9, 10, 11 or 8, 10, 9, 11, these are actually the same thing. That's why these numbers look exactly the same. Okay, so let's move on. So you can see that once we're done with the comparison from group A and B, I mean when we're done comparing all those main terms of group A with all those main terms of group B, then we're gonna be getting only these pairs into step 4. So from group A and B, we're gonna be getting these numbers into step 4. So let's see what we can get from group B and C. Okay, so you can see that I have not written anything here for group B and C. That's because none of the pairs satisfies actually both the conditions. So no match was found, so nothing was entered into step 4. Okay, so you get the point, right? We're only going to put numbers into step 4 if we can somehow match both conditions, the conditions we have explained a few minutes before. All right, so since from group B and C there was no match found, none of the pairs actually matched both conditions, so we have not took anything from group B and C, and that's why there is nothing written over here. All right, so that's how we're gonna be done with group with all the group comparison from step 3. So that's it. Now we are done with step 4. Okay, so let's move on to our next step. So this is what our math looks like right now. So if you can remember, we have actually put some tick marks beside step 2 when we're done with step 3. So now that we're done with step 4, so what should we do? We should definitely put some tick marks beside some of the numbers of step 3. So how are we going to put those tick marks, and where will we put that? So let's check. The rule says we'll put tick mark beside those pairs in step 3 which we have actually taken into consideration in our step 4. So let's see the example how it works. So for the first number right there, 8, 9, 10, 11. Alright, so 8, 9, 10, 11. So we have written these numbers because we actually took into consideration two of the pairs, 8, 9 and 10, 11. So we're gonna go back to step 3 and we're gonna put some tick marks beside those pairs, 8, 9 and 10, 11. Alright, so let's check the next one. So the next one says 8, 10, 9, 11. So we're gonna go back to step 3 and we're gonna put tick marks on the pairs of 8, 10 and 9, 11. Alright, so we just put some tick mark beside those pairs which we have actually taken into step 4. Alright, so this is how the tick marks are placed. You should really check one thing that's written over here. So we have not put any tick marks beside the pairs 1 9 or 11 15, say. So let's check the 1 9. So you may think that I can see that there is a 9 over here and we have taken 9 in our step 4, so why didn't we put a tick mark beside that? Because in that pair we can see that we have only taken 9 from this pair into our step 4. We did not take 1. Alright, so to put a tick mark beside a pair, you need to take both of the numbers of that pair. So for example, for 1 9 or 11 15, we can see that one number is actually taken into step 4 but not the other, so that's why we did not put tick marks beside those pairs. Okay, so for the pairs of 8 9 8 10 9 11 and 10 11, all the numbers are present in step 4, as I have said. That's why we put tick marks beside those. So this is what our math looks like right now after completing step 4 and putting tick marks beside step 3. So let me ask you a question. So can we do a step 5 for this problem? We have already done 4 steps, step 1 2 3 4, so can we do a step 5? Okay, so the answer of this question is that we cannot. So why is that? Why can't we just create a step 5? That's because, as you see, that in step 4 there is only one group visible over here. Alright, only one group. So if there is only one group, then how can we compare that group with another? Because there is only one group. Remember, we actually compared group wise. Alright, so we compared A with B and B and C, and B with C and C and C with D and so on. So at step 4 there is only one group. So since there is only one group, we definitely cannot compare it with itself. So that's why we cannot compare further, and that's why there will be no step 5 for this problem. So now for our next task, we're going to consider those terms in our problem which don't have tick marks beside them. Alright, so this will check for step 2, 3 and 4. So we'll ignore step 1 because step 1 is basically just sequential ordering of all the main terms, so there was no groups involved, so that's why we're gonna ignore step 1. And so we're going to consider those terms which don't have tick marks beside them from step 2, 3 and step 4. These terms are actually important because these terms are known as prime implicants, and our next part of the problem actually depends on those prime implicants. So let's move on to our next task. So this is the math of how it looks like currently. So if we only consider the terms where there is no tick marks beside them, then we'll be getting something like this. So these are the terms which didn't have any kind of tick marks beside them. You can actually go back and check for yourself. So for 1 9 4 6 and 6 7 and 7 15 and so on, 11 15 and 8 9 10 11 and 8 10 9 11. So these were the terms which didn't have any kind of tick marks beside them. So that's why we have taken those terms into consideration and we have named them as prime implicants. Alright, so you may have one question that we have written only 8 9 10 11, so why didn't we take 8 10 9 11? Well, basically they are the same thing. Alright, they're the same thing, they have the same representation, so that's why we just ignored the redundant terms and we have taken only once. Alright, so these are the terms which didn't have any ticks beside them, and these are called prime implicants. Okay, so these are the pairs and these are the binary representation for them. Okay, so we're also going to represent them using variables. Alright, so we're going to represent them using variables now. So in our question, if you can remember, the variables were written as w, x, y, z. You can actually rewind and go back to the question if you want. So the variables, the function was actually defined as w, x, y, z. So these are the variables and we're going to represent these binary numbers using those variables. So let's see how we can actually do that. So these are the main terms and these are the binary numbers, and we're going to represent them using variables. So for our convenience, let's just consider the variables over here, w, x, y, z, and we're going to write them over there so that we can understand better. Okay, so for the first one, okay, for the pair of 19-001. So how can we actually represent that? So what we're going to do is that we're going to ignore the dash, okay, we're going to ignore the dash and represent rest of the bits using corresponding variables. That means as we can see that there is a dash at the first place, so we're going to ignore these variables. We're going to ignore w completely, and for the rest of the stuffs we can see 001, and these we know how we can actually represent them. Okay, for 0 we can write it as x prime, for this 0 we can write it as y prime, and for this one we can write it as z. Alright, so that means our total representation will look something like this: x prime, y prime, z. So for the dash position we have actually completely ignored the corresponding variable, and for the rest of the bits we just considered the variables and written them as it is. Okay, so x prime, y prime, z. So let's consider the next one. So here's the next one for 4601-0. okay, so the first 0 is written for w, so that's why w prime. The second at the second position we get 1, so this is written for x, that's why I have written x over there. Okay, and you can see at the third place there is a dash, so we have ignored y completely. All right, so and move on to the next one, we get 0, so that's why we have written z prime. So whenever we get a dash we're gonna ignore that, and we're gonna represent all our rest of the bits using the corresponding variable. Okay, so by following this same procedure we can actually represent all of the pairs, and this is what it will look like after we're done with the representation with corresponding variables. Okay, alright, so we're done with the representation of prime implicants. So now we're gonna move into our part 2 of this problem.